Okay, so here's an integral that's best suited for using partial fraction decomposition as the technique for solving it. So let's see what we've got. We've got a rational function which is somewhat complicated. I've factored the denominator. So let's recall that as we decompose the denominator, which we'll jump right into, x plus 3 squared x minus 2, we need to decompose it in terms of all the factors of the denominator. So this will be a yet unknown number a over x plus 3, an unknown number b over x plus 3 squared. Remember, we have to build up to the largest power of each term that we see in the denominator, plus an unknown number c over x minus 2. Okay, so there we've got it. So now we have an equation for these unknown constants a, b, and c. So we'll go ahead and clear the fractions. So we can clear the fractions by multiplying by the original denominator, and that'll give us x squared minus x minus 27 on the left-hand side, and then that gives us a, and then whatever's missing on the right-hand side. So we have one factor of x plus 3, and we're multiplying by x plus 3 squared times x minus 2, so this will be x plus 3, x minus 2, good, plus b, so this has two factors of x plus 3, so we have only x minus 2 is missing, and then plus c times x plus 3 squared. Okay, so great. Now what I'll do is I'll flip the left-hand side and the right-hand side, and then I'll multiply out the left-hand side. So let's see, that gives us a, and then if we FOIL this term out, we have x squared, so we have plus 3x minus 2x, so that'll be plus x, and then minus 6, good, and then plus b times x minus 2, plus c times x squared plus 6x plus 9. So we have all of that is equal to x squared minus x minus 27. Okay, so I've cleaned up the board a little bit so that we can focus on this equation. So notice we have a times the quantity x squared plus x minus 6, b times the quantity x minus 2, and c times the quantity x squared plus 6x plus 9, and we want this to be equal to x squared minus x minus 27. So this may seem like one equation with three unknowns, a, b, and c, but we can use the fact that this is a polynomial equation to get three equations out of it by each of the powers of x. So we'll have one equation associated to the power of x squared on both sides, one equation x to the first power on both sides, and then one equation for the constants on each side, so I'll write that as the number 1. So let's see. Instead of multiplying all of this out and extracting the coefficients, we can just look at it carefully. So the x squared terms, on the left-hand side, we get an a from distributing this term. We don't get a b, but we do get a c. So we have on the left-hand side a plus c, and on the right-hand side we have 1. Okay, good. And then for the x terms, so on the left-hand side we have a, and then we have plus b, and then plus 6c equals -1. Okay, good. And then finally for the constant terms, we have -6a minus 2b plus 9c equals -27. Okay, good. So now we need to focus on solving these equations. So I'll clean up the board again, and then we'll look at this. Okay, good. So now we've got our system of equations that we need to solve. So maybe the first thing that I would notice is that there's a term in the first and the second equation, and the coefficient is 1. So that means we can subtract these two equations to get the following. So let's do the second equation minus the first equation. So that'll give us b plus 5c equals -2. Good. And now that coupled with the first equation allows us to solve for a and b in terms of c. So notice this tells us that b equals -5c minus 2. And then this very first equation tells us that a equals -c plus 1. And now we can substitute those into the final equation and solve for c. So let's see what we get. We have -6, and then we'll replace a with -c plus 1. And then we have -2b, and we'll replace b with -5c minus 2. And then finally we have 9c. 9c equals -27. Okay, so let's see what we get when we simplify this. So we have -6 and -c, so that gives us 6c, and then -6. Then we have plus, so that'll give us 10c, and then plus 4, plus 9c equals -27. Okay, good. Now we can combine the like terms on the right-hand side. So we have 10c plus 9c is 19c, plus 6c will be 25c. So we have 25c, and then we have 4 minus 6, so that'll give us -2 equals -27. Good. So we're close now. So 25c equals -25, which tells us that c equals -1. Great. Now we can use these values of b and a along with this thing that we solved for c equals -1 to get a and b. So here we have a is -c plus 1, so that means a is 2, and then b is -5c plus 2, so that tells us that b is 5 minus 2, so b is 3. Okay, good. Now we've solved for our constants and we're ready to go on to the next step. I'll clean up the board and we'll get to it. Okay, so we're finally ready to finish this problem off. So let's recall we started with this decomposition. That led us towards a system of equations for these unknown coefficients a, b, and c, which we earlier solved to get 2, 3, and -1. So now we can substitute those into this integral. So that gives us the integral of 2 over x plus 3 plus 3 over x plus 3 squared, and then minus 1 over x minus 2. And now we're ready. So the first and the last integral are natural logs, and the middle integral can be done using the power rule. So I'll skip the details for that. It's a simple u substitution. So here we get twice the natural log of x plus 3. And then we'll raise the exponent by 1. So this is really a negative second exponent. So raising it by 1 would make it -1. And then we'll divide by the new exponent. Dividing and multiplying by -1 are the same. So we have -3 over x plus 3. X plus 3 to the -1. And then finally minus the natural log of the absolute value of x minus 2 plus our constant of integration. And we're finally done.